Hello, this is Mr. Jackson with physics, and today I want to talk about analyzing forces. I'm going to start off with the idea of Newton's second law. Newton's second law states that as an object experiences a force, that force will cause the object to accelerate. Okay? And what that means is that as a ball, let's say if I take this ball, and if I push on it one time, it moves at constant speed. But if I keep pushing on it and pushing on it and keep pushing on it, it will begin to accelerate. And so there's an acceleration that occurs when a force that is unbalanced, and it means you have excess force. Because right now, if I just push on it, there's no other force hitting it, so it has to begin to accelerate. But if I push on it with another force in the opposite direction, the forces are balanced. So if there's any leftover force, it begins to accelerate. Now the object will accelerate based on its mass and the size of the force. So that acceleration can change if the mass or the force itself changes. That acceleration will either become larger or smaller. So really what we should do is write this as F net. And the reason why we say F net, we want to consider all the forces on an object. So if I have a force on it and it's unbalanced, it begins to move. But if I have another force opposing it, it may not move as much. So we have to look at all the forces. And once we add the ones in one direction and subtract the other ones in another direction, we have what's left over. And that is called the net force, just like in a paycheck. You have your gross pay, but then the government takes so much money, and then so the addition from the business gives you money, but then the subtraction from the government takes away, and what's left over is called F net. So let's look at Newton's second law, and let's look at the forces. So we're just trying to analyze these forces. We'll worry about finding acceleration later on. So I have a couple scenarios here. Let's talk about each scenario. Here I have a person pulling on a box. So we have a force applied. Okay? Or actually, since it's a rope, it's actually a tension. So let me put a T there for tension. So because whenever we have a string or a rope, that would be a tension force. And let's say that there actually is, let's say it's tension that they're pulling, let's say with 20 newtons. But that box is touching the floor, so it is experiencing some friction. And let's say today that friction, that force of friction that it feels on the box goes in the opposite direction, because friction always opposes the direction of motion. It was moving this way. And let's say that friction is 10 newtons. Okay? And newtons is the unit, of course, for force. Well, since they're in opposite directions, the rule is opposites subtract. So we would have 20 minus 10. And then that would give us a leftover 10 newtons, but it would be left over to the right. Okay? So that would be the leftover force I could plug into this equation. So that would be the net force. Let's say I have a person dropping an object off of a building, like a bowling ball. Okay? Well, this bowling ball accelerates. Well, if there is an acceleration, then that means there must be an unbalanced force. So there must be some kind of force. So we know that gravity pulls down, so we're going to call that the force of weight. Okay? And let's say that that bowling ball weighs 5 newtons. Okay? Well, if there's no other forces, if it's round and it's just dropping for a little ways off this little hill or building, it doesn't get enough momentum to get any kind of drag or air drag, then basically that's the only force. So the net force is just going to be 5 newtons, and the net direction would be downward. Okay? Because there's only one force. Let's look at another situation. Let's look at this car driving down the road. So we have this car driving down the road. Let's say that it has an applied force applied from the engine, okay, or it could be thrust, either one. And our force applied, let's say it is 100 newtons, okay? And then let's say that it's going fast enough that there actually is force of drag due to the air. And let's say that there are, maybe 150 newtons of drag. And let's call this, I apologize, let's change this number out front here. I had an example. Let's change this number to 500. Okay, and let's say the force of friction on the road, because there's a road here, that there's also another force of friction opposing motion. And that force of friction, let's say that that is 350 newtons. Okay? Well, now we look at our forces, and so we know we have drag, and we know we have friction, and we have this direction, so we want to find what's leftover force. So we have 500 minus 300 minus 150, and we end up with 0 newtons. So what does that mean? That means the object does not accelerate. If there's no force, okay, if F net is 0, then that means there is no acceleration. It doesn't mean it's not moving, but on the highway, if you're going at constant speed and your engine is pushing, that means that whatever friction in the air and whatever friction there is on the road, they're canceling out your car, so you're just driving down the road at the same speed. You still have to apply a force because you have to match whatever friction is on the road, so you're not accelerating. Now, if you wanted to accelerate, you'd have to go over 500 newtons to pass the person in front of you or whatever you want to do. So remember, if F net is 0, there is no acceleration. Okay? Let's look at this rocket taking off in the air. And let's say this rocket has some thrust, so force of thrust. And let's say that that is, let's give it around, 300 newtons. Okay? And let's say that there is a force of weight, because there's a planet and a gravity, so we have force of weight acting down, Fw. And let's say that the weight is 100, let's say it's 200 newtons. Okay? But there is drag on the plane, on the rocket, because it is going through the air quite fast. And let's say force of drag is 150 newtons. Okay? And so we do our F net, we have 300 newtons from the actual push upward. And then we have 200 opposing, and since they're in opposite directions, we subtract. And then we have another 150, newtons from the drag. So we get an answer of negative 50 newtons. Well, what does that mean? Well, we were moving in this direction, so that means we're slowing down. So this negative sign, negative, means deceleration, because it is the opposite of what was considered the thrust or the moving force. So in this case, we would see deceleration, okay? Because we have a negative force. So F net is 50, but it is downward, and since we know we have more upward, we might consider it to be negative, if that makes sense. Okay? Let's look at our last couple scenarios here. We have a person riding a bicycle, and let's say they're pedaling, so they have applied force. And let's say that it's going to be 100. Okay? And they're experiencing a little friction. Okay? And we will assume it's not air drag going on with this. So we have a little bit of friction. Let's go force of friction, 80 newtons. Okay, so they're actually accelerating. Our F net, we get 100 minus 80. So we have a net force left over of 20 in this direction. Okay, but I have another question for you. I have a force right here, and so I don't have anything else written down. It's unbalanced. So there should be acceleration going down because there is some weight of this bike on the road. But we know the road pushes back up. And so if we ever know there's a situation where there is no acceleration, then there must be an opposing force canceling it out. Because remember, no acceleration means all the forces in the opposite directions have canceled out. So if these two are the same, there's no acceleration this way. If these two are the same, there's no acceleration this way. And we know we're not accelerating the ground. So there must be a force up. Well, what could be that force up? Well, in our notes on types of forces, that is a support force called force normal. And so that force normal must also be 50 newtons. Otherwise, we would have an acceleration in this plane of motion. So we have this is also 50 newtons. So I wanted to explain that. So let's say we have a person falling now. They're out, they're skydiving. So we have force of weight. And let's say this person's weight, force of weight, is 100 newtons. Okay? And as they're falling, they don't want to hit the ground fast. They want to hit the ground slower. So they need to bring in some friction. They have a force of air drag, but that's still not enough to stop them from when they hit the ground to survive. So what they do is they pull a parachute. Okay? And this parachute ends up creating a force of drag extremely large because of all the surface area. And let's say that force of drag is now going to be 160 newtons. So what we do is we have 100, because this was winning, now minus 160 newtons. So we end up with negative 60 newtons. And so we know that as the person, once they open the chute, they are now again decelerating. Okay? So that would be deceleration. And so the leftover force in this case would be up. So the F net is up compared to what I called down as being my positive this time. So we'll get into the idea. We want to think about whether something's increasing or decreasing in its speed. We need to analyze, is there motion? What direction is that motion? Here's the motion. It's going this way. Here the motion was down because they're falling downward. Okay, the motion is down, and so that's my positive direction. Here my motion is to the right, and here my motion is down again. So we need to look at the motion and what's going to happen. Okay, that's very, very important. The last thing I need to mention when we're analyzing forces is the idea of mass. One of the things we haven't talked about enough yet is the idea of mass. We said over here in our Newton's second law that our acceleration is dependent on how strong the force is, and we just got done analyzing forces, but it also depends on how massive the object is. If you're pulling on an object, so let's say we're pulling with, let's give an example of 100 newtons in both cases. Okay? And with those 100 newtons, you're pushing, you're pulling, so it's a force of tension or applied, it's okay. And we have a small mass and a large mass. Let's say that the friction is the same. Okay? So let's say they both, because they're rubbing on the floor, that they both experience some friction. And let's just give it the same amount of friction. Let's just say each one experiences 40 newtons of friction. So we subtract those. Our F net will be 60. Okay, and it will of course be in this direction. That'll be the extra. So we'll have acceleration in this direction. Okay, but how much acceleration? Well, if you think about it, let's say that there's a mass, and we can give them numbers. They actually have numbers like kilograms. So let's say that this is a really massive object. So let's say this is 20 kilograms. That's a big box. And let's say this is a smaller box, like 5 kilograms. Well, what's going to happen is you can see if we have 60 newtons force, and then we have a mass of 20 kilograms, then the acceleration is going to be 3. But if we have 60 newtons, and we're applying extra leftover 60 net newtons on a smaller object, then what's going to happen is we're going to end up with a much larger acceleration. And in fact, that's 12 meters per second squared. So what I need you to understand is when the object is massive, and mass is due to the number of protons and neutrons and electrons and all the stuff that makes up the matter of that object. If the mass is large, then that's going to slow down how much that force can act. If the mass is smaller, then that force can have a greater impact and have more acceleration. So mass is the amount of matter in an object. And that can be all the protons and neutrons and all those little pieces that we have inside of material. Okay? But I want to point out one more small idea, is the difference between mass and weight. Weight is the pull of gravity on an object's mass. And if that gravity is greater or less, the object's weight will change, but mass and weight are not the same thing. Let's say we have these two boxes that are the exact same mass. So inside these boxes, whatever's in there, these particles inside weigh up to 10 kilograms. Okay? And so we put it on Earth. Earth has a much larger, we'll just say a pull of gravity of 10 meters per second squared, because it has a much greater acceleration down. The moon, however, only has roughly about 1.6 meters per second squared, so it's much smaller. So what happens is when you multiply these things out, this would have a force of weight of roughly 10 times 10, 100 newtons, okay, to pick that up. But this object, if it was the same exact object on the moon, then this one, the force of weight, would be 1.6 times 10. It would be 16 newtons. So the weight is less because the pull of gravity is less. So weight can change if you can put it on different planets. But the mass does not change. So mass is unchanging when it's the same object. But gravity, since it does change on planets, it does have an impact on the weight. And we'll do more on weight later on. I just wanted you to understand what's the difference between mass and weight, okay? And how those actually can sometimes interact and impact our force problems, okay? Well, that is what I need you to know when you're analyzing forces. Thank you very much.